Hey, this is Mr. Weisfeld. We're talking about scientific procedures today. How do you write those? And let's practice that. So what I've got here is a form that we like to use, a template for how you would write a scientific procedure. Put your name on it, Mr. W. Really important part of writing procedures is to differentiate between a manipulated variable and the responding variable. Remember that the MV, a manipulated variable, is the variable you change in your experiment, and you change it in a very specific and controlled way. The responding variable, remember, is the variable you measure. We say it's the responding variable because based on the manipulated variable, when you change that, it responds to it, like it affects it. So, and I said a little while ago that there are control variables or constant variables. Those are the ones that we're not changing, that we need to keep constant in order to make an accurate decision about how much the manipulated variable affects the responding variable. So let's do this experiment today. I'm thinking about paper airplanes and paper clips. And somebody said to me once, they said, I think if you put some paper clips on your paper airplane, it'll fly a little better. So let's take a look at this. How does changing what am I going to change? I'm going to try and maybe make a paper airplane but keep everything else the same. Well, the whole question is, I'm going to have the number of paper clips affect now I wanted something I can measure. And so let's see, what can I measure when it comes to paper airplanes? I think I can measure the distance. So let's look at how does changing the number of paper clips affect the distance a paper airplane flies. That's basically it. That's my scientific question. And once you've got a scientific question, you can start writing your procedure. So let's go. My manipulated variable is the number of paper clips. Now you can imagine I could put a whole box of paper clips on my paper airplane, and then it becomes kind of a paper clip bomb, and I could throw that. But let's think about kind of that that number of paper clips that just helps versus doesn't really help. So let's try maybe, I'm thinking about maybe 2 paper clips, and then I'm thinking about maybe 4 paper clips, and I'm thinking about maybe 6 paper clips. So 2 paper clips, 1 on each side, and then 4, maybe 1 in the front, 1 in the back, and then 6, tweaking that a little bit. So those are the conditions for my manipulated variable. You need to set those. Not only are you telling yourself what you're going to do, but you're telling anyone else that looks at this procedure later what you did in your experiment. My responding variable, like we said, is the distance the paper airplane flies. I haven't said a lot about how I'm going to throw the paper airplane, or how hard or what kind of angle I'm going to throw it at. But I think those things you can talk about under control variables. So we'll get there in just a second. You need a tool to measure your results. This is very important. Science is all about measurements, and the tool you use is critical. So in order to measure the distance my paper airplane goes, I'm going to have to use either a measuring tape or here at school we can use the squares on the floor. Each of those is a foot, and you can get a good idea of how far something goes or moves by counting the number of squares on the floor. My control variables. If you change too many things at once in a scientific procedure, remember, it doesn't tell you very much. In other words, you get kind of confused about, well, was it that caused my airplane to go fly farther because I threw it harder? Or was it the paper airplane or the paper clip? What was it that really made it go farther? So these are like, you really have to stick to these. And so let's put that down here. How hard you throw the airplane. This had better be the same each time. how you throw as well. Are you going to tip the thing up, tip the thing down? Maybe you work out a way to kind of put it on a stick and then you pull the rubber band back and then let it go from that. All of that shows that you've thought about whether paper clips are going to help you or not. Then let's talk about the paper you're going to use. You're not going to change the paper in the plane. And you're also not going to redesign your airplane in the middle. So once you pick, how you folded it, how it's stuck together, you really need to keep, it's not the redesign, it's just the design of the plane. So you're not going to change the paper that you use for the airplane, and you're not going to change the design of the airplane. All right, so that's your manipulated variables, your responding variables, your control variables. Just an aside while I'm talking. It's important that you get procedures down. You're going to do a lot of science in high school, and I want you to make sure that you have done your best to make sure that you're writing good procedures. There's an end-of-course biology exam in Washington State. You all have to pass that to graduate. It may go away someday. It's not gone yet. You need to write good procedures. So this frame is helping you put down on paper what it means to write a good procedure. Your materials list, this is what do you need? What do you need to do this experiment? So we saw a measuring tape. Let's put that down. You need some paper, airplane paper. And you need some paper clips. There's really not much besides that you need. And if we think of it, we'll put it down, but that's the material list. Your procedure now. There's a little saying that we like to use called gather, label, keep, be sure, perform your test, record, repeat. If you could learn that into a little chant, that would be great. So let's practice. Gather, label, keep, be sure, perform, record, repeat. Gather, label, keep, be sure, perform, record, repeat. Notice when I'm looking at you, I'm not looking at what's on my screen. So you can look away and say this. Gather, label, keep, be sure, perform, record, repeat. All right. That's going to be a little guide for how you're going to do this procedure. And so gather materials, I've listed them right there. You need to list everything you need, nothing more, nothing less to get the job done. I mean, if you want to say a little tape to hold your airplane together, you better be sure that you list that there. All right. You label your manipulated variables, so or your airplanes. It may be that your airplane changes when you add paper clips, like you tweak it a little bit. You probably ought to go back and take away paper clips, you know what I'm saying? So, same airplane, same folding, 2 paper clips. Now put 2 more on. Now put 2 more paper clips on your airplane, right? So label airplanes 2, 4, and 6 with the conditions. That was the number of paper clips that you're using. So first one, 2 paper clips, let's say on the wings. 2 paper clips, second change in the variable. 2 paper clips on the wings, 2 on the tail, let's say. And then 2 paper clips on the wings, 2 on the tail, and 2 on the nose. In other words, we're thinking about how to keep your airplane balanced. We're trying to figure out what helps the airplane go. And remember, if you learn anything while you're doing your experiment, feel free to take notes in your notebook. write in your notebook any ideas you have as you do your experiment. Okay, keep the same control variables. So what did we say? We said same folding, same paper. I guess that means the same airplane, right? And we said, back up here, we said how hard you throw. And throw the same way. Those are going to be very important. The same throwing technique that you use. So this, we don't talk about it very much, but by using good control variables, you increase the validity of your experiment. Now, we've talked about reliability, but validity is, can people trust your procedure? Okay, so when you perform, you need to tell me in detail the steps you're using when you do your procedure. So you want to say fold airplane, maybe test it a couple times, right? Make sure it can fly. Then add 2 paper clips, right? Throw airplane. Maybe you're going to use a little rubber band or something to launch it, like a slingshot or something, but throw airplane same way each time. Then measure where the airplane falls. If it falls and then slides, maybe you're going to decide that you want the maximum sliding because, hey, it takes energy to slide too. That's still pretty good for an airplane. But you have to decide some of those things. Measure where the airplane falls and do that 3 times for 2 paper clips. Notice you'll see when we get down a little bit lower that on this frame that I'm repeating myself a little bit. That's okay. Better to repeat yourself and get some more points than to miss some points. Okay, so change to 4 paper clips on the same plane with the same folding. Throw the airplane. Measure where it falls. And do that 3 times, right? With 4 paper clips. When you're doing a scientific experiment, it's not about that I want you to do something 3 times, that I'm just trying to make your life difficult. If you're getting something fairly consistently, then you can be pretty sure that you have a good experiment that's reliable and valid. So 4 paper clips, it might take 3 times, it may take 6 times, it may take 8 times or 9 times. I want you to know I did it the same way. It had 4 paper clips. It landed the same place pretty much each time. That's the kind of reliability that we think is in the natural world already, that if you do something one way, the same way every time, it'll come out the same. But that's also what we want you to get good at as scientists. So then change to 6 paper clips. Remember, it's the same plane. Remember, you're going to throw it. You're going to, in the same way. You're going to measure the fall in the same way. Or measure the distance. And then you're going to do that 3 times for 6 paper clips, okay? It is very helpful sometimes to do a table. And so let me just say that if you have 2 paper clips, 2 PC, 4 PC, and 6 PC, you have a table right here that you basically can say, here's 3 trials. We don't tell you to make a table, but I tell you what, people who make a table tend to get more points. So here's the distance, number 1, distance number 2, distance number 3, And what do you get when you have a lot of the same things